Hello everyone, welcome to our channel Everyday E-Learning. In today's video, we will learn and practice a couple of problems from the topic conditional probability, and for that we will take a couple of problems. So this one is our number one problem, and we will solve this one and try to understand how we can easily solve problems related to conditional probability. Now for solving this problem, we need some donations so that we can make it a bit smaller than writing a lot of sentences. So you will use the following symbols. So as you see here, we will use the following symbols to make it smaller. Now let's start with number A. So in number A, we are asked, if a card is drawn at random from a pack of cards, what is the probability that we get aces of heart given that the card is from the red suit? So we can write it as probability of aces of red heart given that the card is from red suit. So we can denote red suit using R. So we know the formula for conditional probability, that if we have something given in this sort, we can write it as a heart intersection R divided by probability of R. So we can now put on the values. So total we have 13 plus 13 equals to 26 red suit cards, and from the 26 red suit cards we can have only one heart card that will be an ace. So the probability here will be 1 over 26. Now let us move on to number B. In number B, we are asked to find out the probability of a heart given that the card is from red suit. So we can use the same formula here. Probability of heart intersection red suit, it means probability of heart and it will be red by probability of red suit. So total we have for red suit 13 hearts and 13 diamonds, so total 26, and out of those 26 red suit cards we will have 13 cards that are of hearts. So this one is 13 over 26, which is 1 over 2. Now for number C, we have to find out the probability of card from red suit given that it will be heart. Alright, we can also denote it like this, heart, or even H from here. So it will be probability of red and heart by probability of heart. So already we used this one value in the previous one, that is probability of red and heart. 13 over, we have in total 13 hearts, so that will be equals to 1. Moving on to number D, we have to find out the probability of heart given that the card is from black suit. So we can rewrite it like this, probability of heart and black suit by probability of black suit. Now in this case, we know that a heart card can never be from a black suit, so this is not possible. So this will be an empty set, and this result will be denoted by this one, or we can also use this one. Moving on to number E, we have to find out the probability of king card given that the card is from red suit. So we can use the formula of probability of king and red divided by probability of red. So out of 26 red suit cards, there can be 2 kings, and total we have 26 red suit cards. So the answer will be, if we simplify it, 1 over 13. Now let us move on to the last one, which is probability of king given red picture card. We don't have any symbol for that, so we'll write the full one, red picture card. So formula for that will be probability of king intersection red picture card divided by probability of red picture card. So we have total red picture card 6, as you know, king, queen and jack, 3 for hearts and 3 for diamonds. So we have total 6, and out of those 6 red picture cards we can have at best 2 kings, one from heart and one from diamonds. So the result will be 1/3. We will now move on to our next problem. Let me move a little down for that. So this is our next problem. Sorry for the glitch in the screen. Now I drew this box to write the values that are obtained from this problem. It will help us to solve the problem easily. Now we can see in our second problem that a gene can be either type A or type B. So it can be type A. We'll denote it as A, and it can be type B. We'll denote it as not A. And then we again have it can be either dominant or recessive. So it can be dominant. We will denote it with D, and it can be recessive. We will denote it as not dominant because that is the only option left. Now we are also given some values as you see here. So you'll also note that down. It is said that if the gene is type B, then there is a probability of 0.31 that it is dominant. So we can write it as probability of dominant given not A because it is B is equal to 0.31, and it is also given that probability of gene is of type B, that is not A, and it is dominant. So the value is 0.22. So from here we can easily find out the probability of the gene being type A, which is to be found. From here we can write it as D given A naught is equal to probability of D and A naught over probability of A naught. So from here we'll find out the probability of a gene is not A is equal to, we are given this value which is 0.22, and this one comes down, so this one is 0.31. So we get probability of a gene being not A is equal to 22/31. Now we can easily find out the probability of the gene being A by subtracting probability of the gene being not A from 1 by using this formula, and we have 1 minus 22/31, which is equal to 9/31. This is the answer. So I hope you understood the problems related to conditional probability. I hope you will be able to solve those. If you have any confusion or any problem, feel free to write down below. And thank you for watching this video.